So now we're going to take a look at a few ellipse applications, and I'm going to complete most of this with you, and then I will tell you what your assignment is to post on Google Classroom. All right, so how about number one? An arch of a bridge over a highway is semi-elliptical in shape, and it is 60 feet all the way across. So this is 60, which makes this just 30 and 30. The highest point of the arch is 20 feet above the highway. Add the information to the diagram below. Let the center be at the origin. So this is 0, 0 right here. Write an equation for the ellipse. Well, it's a 0, 0 ellipse. That means that x squared plus y squared is going to equal just 1. And I need to solve for a squared and b squared. The longer axis is going horizontally. My a value is 30, centered to the endpoint. So 30 squared would be 900. And my b value is 20. 20 squared is 400. So there's my equation. It says use your equation from part B to determine the height of the ellipse 20 feet away from the center. I'm going to plug 20 in for x. I am trying to find this point on the ellipse, 20, comma, what? They want to know what is the height of the ellipse when the x value is 20. We're going to plug 20 in for x in our equation. And we're going to leave y in the equation. And we have to algebraically solve for y. So our first step to get y by itself would be to take the number 1 and subtract whatever 20 squared over 900 is. I'm going to show you just typing it into my calculator. So 1 minus 20 squared over 900. So now I have this decimal 0.555 repeating. So I have y squared over 400 equals 0.555 repeating. What would be my next step to get y squared by itself? It would be multiplying both sides of the equation by 400. On my calculator, I'm just going to multiply my answer times 400. So y squared is 222.2. My last step would be to take the square root of both sides. So the square root of my number is 14.9, and it's in feet. So the height of this archway would be 14.9 feet. So why is this useful? So now you've got a truck. It is 12 feet 6 inches tall, or 12.5 feet. It wants to go under the tunnel. If one side of the truck is on the center stripe, what is the maximum width of the truck that could fit under the arch? So your truck is going to go under the bridge. I shouldn't have drawn it to that point, but let's see. We don't know the width of my truck. We just know that the height of the truck is 12.5 feet. So this truck could actually be wider than 20 feet, right? Because at 20, the height of the bridge was 14.9. So I want to go over x to figure out where is this question mark going to be 12.5 feet tall. So I'm going to have you finish this equation yourself for part D, but we are looking for x this time, and we are going to fill in the number 12.5 for y in the equation. So I'd like you to solve that equation for x and tell me what the answer is, and you're going to use kind of the same process that you used or that I used on part C. So solve for x. So that's the first one that I'm going to be looking for that you've completed. All right, question number 2. A hall with a semi-elliptical ceiling, so here's the ceiling and then here are the walls, is designed to be a whispering gallery. So a whispering gallery, maybe you've never been to the United States Capitol or certain train stations, but they usually will put marks on the floor because those are where it's the foci of the ellipse. Because anytime, remember that string is going to bounce and basically bounce off this elliptical ceiling right back to the other focus, because the sum of those distances is always equal. So it's a special property of ellipses. I can whisper from here 20 feet away, and this person will hear me loud and clear. So we're only looking at this top part of the ellipse right now. So the length of the room is 100 feet. The foci are located 25 feet from the center. So your C value is what's 25. I guess our A value must be 50 because the total length is 100, right? So 50 and 50 in either direction. Assume the vertical walls are 8 feet. So at the very end, this part is going to be 8 feet. I need to solve for B because I want to know how high is the ceiling at its center. So I'm looking for this total height of the room. The ellipse is up here. So my B value is going to be this part of the height, and then I'm going to have to add 8 feet for the rest of this flat wall. I'm going to use A squared equals B squared plus C squared, and I'm going to plug in A and C, solve for B, and don't forget, once you have B, you need to add the extra 8 feet at the end. So you should be able to pause the video and solve example 2. All right, example 3. The moon travels about the Earth in an elliptical orbit where the Earth is at one focus. So that's something that's important to note. The Earth is not at the center, it's at a focus. The major and minor axes have these lengths. So that's the length of the whole major axis and the whole minor axis. First, they want you to just find A and B. Well, let's see, which of these is longer? 768 is longer. So A is going to be equal to 768,806 divided by 2, because the major axis is all the way across. The A value is just half of that. So I'm going to take 768,806 and divide it by 2. So 384,403. My B is going to be the same method, 767, 746 divided by 2. 767, 746 divided by 2 is 383873. So do you think the eccentricity is going to be very big? The major and minor axis are pretty equal in length. Find the value of C. So if I know that A squared equals B squared plus C squared, I can plug in my information. 384,403 squared equals 383,873 squared plus C squared. So I'm going to have to take this big number, square it, and then subtract this big number squared. That'll be C squared, and then take the square root at the end. So let's just do that right on our calculator. I already have A and B sitting here on my calculator. So I'm just going to arrow up. I'm going to take A squared and subtract B squared. And then I'm going to take the square root of that to get C. So C must be 20,000. C is 20,178.9. So then it says, so I could find the eccentricity. I should have asked you that, but eccentricity, let's just take eccentricity, for example. If I take the 20,000 number, divide by 384,403, the eccentricity is 0.05. That's a darn small eccentricity, right? Because it's a very circular orbit. All right, so this last piece, the apogee and perigee represent the furthest and closest distances from the Earth's center to the moon's center. So this is the Earth. The Earth stays put. So when the moon is here, the moon is actually closer to the Earth than when the moon is here in the orbit. Earth is staying put, the moon is circling around, so the Earth is at one focus, right? Remember we said? So if the Earth is at this focus, the moon gets just slightly closer at perigee and then slightly farther away at apogee. Have you ever heard of a supermoon? The moon is actually a little bit closer in the sky when it's a supermoon. All right, so we want to actually determine how far the moon is actually away. So I want to use A and C to determine perigee. Let's put in the information that we know. Apogee, this to here would be A, but here to here is C. So I could do apogee by adding A plus C. Well, what about perigee? So perigee is from here to here. Well, if this is A, can I do A minus C and I'll have this remaining distance? So for perigee, I'm going to do A minus C. So why don't you do that? You can finish and you can type on your calculator A plus C, tell me what you get. A minus C, tell me what you get. Example 4. The band wants to form a perfect ellipse on the football field at the next game. They will use a rope with 2 people holding the ends at the foci to determine their positions for the ellipse. A football field is 300 feet long and 160 feet wide. The band wants to make as large of an ellipse as they can. How long should the rope be? So remember when we were talking about A, B, and C? We talked about an ellipse and how if you pick any point on the ellipse and you mark a string that stretches to the 2 foci, that is your string, right? So this string will never change in length. It's always fixed here, and we drag it around the ellipse. So then we marked off this point on the same ellipse. So it has the same foci and it has the same string as up here. So when I stretch the string out, I'm drawing it, it's supposed to be perfectly straight, but I want you to see the string. This string is the same as the length of this string. How long is the string? So we said if we disconnect this little tiny piece and we put it right here, won't that piece fit perfectly? So the length of the string is always 2A. So the length of the string, 2A, is going to be 300 feet. Because that's the length of the major axis in this example. Where should the 2 foci be relative to the center of the football field? So they just want to find C. So we need to do A squared equals B squared plus C squared to find C. Let's not be tricked here. 2A is 300. A has to be 150. So 150 squared. B would have to be 80, because that's half. 80 squared plus C squared. So I'll let you finish that. You need to solve for C, and that's what they're asking you. How far should the foci be from the center of the field? So you've got just a little piece to calculate on each of those examples. I only need you to submit page 405 front and back today in Google Classroom. Thank you.